All right. Okay, so we have a redox problem, and then there's a question that is going to give you some information about a solution along with a gas being added. And the question is, what is the pressure of ammonia and nitrogen in the end? So first we're going to start with the redox reaction. I do want to point out we don't have states of matter in here. So the permanganate should be aqueous. It's going to be reacting with ammonia that dissolves in water. So this really should be aqueous, but that's going to be related to the pressure of the ammonia in there, and it's going to dissolve in water pretty well. So that might make this problem a little bit complicated. So what we're going to do is just ignore that, and we're going to totally treat ammonia as a gas for this problem. And then we're going to do the same thing for nitrogen. For nitrogen, it is accurate. Nitrogen not going to dissolve in water very well. And then we'll have manganese ions, but this should be aqueous as well. And so this is all happening in a basic medium. So when you see that, you should recognize that you're going to be using hydroxide as your ion to balance the charges. So let's go through this. First thing I would say is you got to look at each element that is not oxygen or not hydrogen, each element that is changing its oxidation state, and write the oxidation state. So manganese, look at this, we've got oxygen. Oxygen's -2 times 4 is -8. So manganese is +7. Hydrogen here is +1, so nitrogen's -3. Nitrogen here is 0, and manganese is obviously +2. So you could deal with the reduction half reaction first or the oxidation half reaction. It's really your call. Why don't we just start with manganese permanganate. So we have the reactant, the product, and we need to remember our vowels. So we got A. First thing is atoms. And there's one manganese atom on the reactant side, one on the product side, so we're okay. Next is electrons. Electrons. So this is where we see the charge, and we make sure that this charge is accounted for. So we've got +7 going to +2. That means we need to add 5 electrons on the reactant side, and that makes this a reduction. I need to get rid of this soon. I is ions, and we just said this is a basic medium, so we're using hydroxide for the ions. We look at the charge, we got 5 minus and -1, so we got a total of -6 on the reactant side. We've got +2 on the product side, so we need enough hydroxides over here to make the product side -6. Get rid of this now. That is +8 OH. All right, so the O8, the hydroxide brings that down. Now they are both -6. Okay. Next is oxygen. So oxygen atoms, we have 4 oxygen atoms on the reactant side, we have 8 on the product side, so we need 4 water molecules. This gives us 8 oxygens on the reactant side. Hope you can see that. That's good. That's fine for our reduction half reaction. Next thing is the oxidation. All right, pay attention to A, E, I, O, U. U is for unite, so we need both both half reactions finished before we do that. We'll start with atoms, and if we see the reactant side has 1 nitrogen atom, the product side has 2, so we need 2. That balances our atoms. Next is electrons. We have 2 nitrogen atoms going from -3 to 0. So 2 nitrogen atoms would require, or would give off 6 electrons. All right, that takes care of our electrons. Now we need ions. And this side is -6. This side has no charge. So we're going to add 6 hydroxides to the reactant side. Takes care of ions. Next is oxygens. 6 oxygens on the product side, none on the reactant side. So we are going to add 6 waters. And that's our oxygens. All right, so we've taken care of our reduction half reaction, our oxidation half reaction, and now we just need to unite it. And to unite, we need to make sure that our electrons cancel out on both sides. We don't see electrons in balanced equations. There's 5 electrons on the reactant side, 6 electrons on the product side. So we need a common multiple, and that would be 30. So we're going to multiply the top by 6, multiply the bottom by 5. And that's going to get rid of the electrons. So we just transfer this. Okay, so we've got all our reactants transferred. Now we need to transfer the products. 6. Okay, just all I did was take down everything, and now we need to look and see, does anything show up on both sides of the reactions? And we see that water does. So we've got 24 waters on the reactant side and 30 waters on the product side. So I'm going to get rid of water on the reactant, and I'm going to get rid of 24 waters on the product side. And the next thing is hydroxide. There are 30 hydroxides on the reactant side, 48 on the product side. So I can get rid of these hydroxides as well. 30. Yeah. So we're going to have 18 hydroxides on the product side. So that is your complete balanced equation. You're going to use that to answer this question. Figure out what's the limiting reagent, excess reagent, or limiting reactant, and then how much nitrogen gas is produced. All right, so we'll do that in a different